So on 2.3, this is also graph of a function. We have discussed this. Any function can be given as graphs, and we know some properties of these graphs, right? What are the properties we already know about when your graph is given? What are the properties? Anytime you see a graph, what does it come into your mind when you see a graph now? It's a function or not? Very good. Okay? You just don't see graphs as, oh, this is just a graph. No, now you know some properties. Okay? So one property is this a function or not? What's another property that we discussed?
It has to be a real number. It has to be a real number.
A function has to be a real number. Certain functions can give with a real number, like horizontal line functions, right? If y is equal to 3, that's a function too, because it's a horizontal line, right? So certain functions can give with a whole number. Yes, those are straight lines, right? We discussed that in the first week. What are the other properties that we know about functions? You guys have done on most of the functions. We discussed those. We talked about those. Slope of a function, but we only talked about slope of a function when the function is a straight line, right? We did not talk about slope of a function when the function is a what? Curve, right? We also have straight line function, we have curves. So right now we are doing all kind of curves, functions with all type of curves, right? So whenever we have a curve, there is a slope, but the slope is changing instantaneously. Okay? You see, slope at each point on a curve is different. That's why the slope is changing. So that's what we did, the different quotient. That's the way to find the slope. When you guys go to Calculus 1 class, you will define that, what that means. So that's part of coming up with this. Kind of gave you a brief discussion on that. You don't have to worry about it now. Okay? Now you know how to find what? What did we cover last class meeting? Domain. The different quotient. That means slope of a curve. That's all you need to know. Okay. So what are the other things that we have to know about functions so far? Domain. Very good. Domain. Didn't we find the domain of all the functions that we graphed and we discussed, right? All type of function, domain. So yes, domain of a function. Every time you see a function, now first thing you need to do is, oh, what's the domain? Domain is all possible x numbers or independent variable, right? That can be used to this whatever the function that you are discussing, right? Or you are graphing, right? What else we know about function? Range. When it's domain, then there's a range. So far you know these properties of function, okay? Okay, so that's the review so far. So chapter 2.3. Page 201, we are going to discuss, actually we did discuss vertical line test, so finding the domain and the range of a function, we did that, so it's 2.2, 202, page 202, we discussed, so properties of functions. So this is assuming whatever the graph is a function, okay? Now, whenever we see a graph, first thing we're going to determine if this is a function or not. After we know that this is a function, we can discuss the properties of functions now, okay? So the first thing we already know is what? Domain, we discussed this. We have to give the domain in terms of
Function.
interval notation. Very good, interval notation. Okay. Or you can give, if it's like only whole numbers, you can give in set notation as well, right? Domain. And then we also need to know range, domain range. And what else we know, guys? We discussed this in chapter 1.7, 1.8. We discussed this when we were discussing graphing a parabola.
The vertical line.
Vertical line test is to determine whether a given graph is a function or not. What are the properties we discuss of a function? You already know this really well. You already found the answers to this.
For one x, there can't be more than 2 y values.
What?
For one x value, there can't be more than 2 y values.
Yeah, find the x value.
Oh, I'm saying there can't be more than two or more y values for an x value.
Oh, that's the definition of function.
Yeah. Oh,
Okay? That's the definition of function.
Okay.
So once you know it's a function, right? What are the other things that it's important to us? We discussed domain, we discussed range.
Ordered pairs.
Ordered pairs? Yeah, we need to have ordered pairs to graph the function. Okay? So that's part of graphing. We have to create I'm just saying we have done all the graphs and we have discussed all type of functions that we have discussed so far. Okay? So what are the other things you have come across in a function? We discussed this class meeting before and also meeting before that, 1.7, 1.8. I mentioned this word many times. What's the value? Last class meeting, you guys had this as a quiz question too. What is it? Zeros of functions. Very good. Zeros of a function, right? We discussed zeros of a function. What is zeros means?
Possible x values.
Zeros of a function, what is zeros means?
All the possible x values.
All the possible x value of what? This all possible x values is domain, right? So what is exactly zeros of function means?
Fx equals 0.
When
Fx equals 0.
fx, the y value, right? When the y value is equal to 0, what are the x values? In other words, what is zeros of a function means? What are we talking about there?
The x
The x-intercept. So this language, they say zeros of a function, but they are literally saying x-intercept. So you guys know I gave the definition for x-intercept. X-intercept means where the graph crosses or touches the x-axis. So zeros of a function means what? Find the x-intercept. There will be a big problem on this test coming up. I'm going to discuss some other properties of functions today. And given a graph, read the graph and have lots of questions asked according to the properties of the function, like domain, range, zeros, where the function is increasing, decreasing, constant, lots of questions like that. Okay? So this is where we covering the properties of functions. Okay? So you already know domain, you already know range, you already know, what is it called? Zeros of function, which means x-intercept. Okay? Think that you're going to teach this to someone. Think that you're going to teach it. Then how are you going to organize your thoughts and tell exactly what you're supposed to say. Okay? So zeros of a function means x-intercept. That's where we are going to discuss this. So we already discussed this, so this is actually then review. Remember, we make the function fy is equal to 0, right? F of x equal to 0 and solve for x, right? So zeros So this means review, definition is, this is on page 202, definition is use of function f is all x values when f of x is equal to 0. All x values which when f of x equal to 0. Only all x values when f of x equal to 0. Okay? Only when x is okay. So x-intercept, in other words, is the x-intercept. We know how to find that. Okay, so and we did some examples for this last class meeting, right? So I'm not going to cover this. This is also reviewed. We have discussed that before. Okay, so now we are going to cover number 4. This is all properties of function, page 203. We have, this is new guys, increasing, decreasing and constant function. This is in the little box that you have on page 203. Increasing function. So the definition for this is, a function f is increasing function x is increasing on an interval if for any x1 and x2 in the interval. I'll explain what this means. In the interval where x1 is less than x2, the word where is not there in the book, I wrote this, additional. Where x1 is less than x2 implies f of x1 is less than f of x2. So let me explain this. So what this means is this. We are going to pick any two x values, where if I pick x1 here and x2 here, you know the values of x1 is x2, x1 is always less than x2. In other words, we have to pick x1 to the left, x2 to the right. Okay? So this is a condition that must satisfy in this definition. So you guys, we are going to read these little definitions right now. You have read definitions before and understood exactly what it is. Now you are reading some new definitions. By reading and understanding these definitions, you are building up your blocks now. Building, understanding mathematics for higher math. Okay? So pre-calculus class, there's lots of tons of definitions and theorems. Okay? So this is like, this definition, understand exactly what it says here. When this is happening, what else? When this condition is given, what do we need to have? What is f of x1? What is for x1, what is f of x1 mean? What is f of x1 means? Y value. Y value for x1, the y coordinate for x1, right? What is f of x2? Y coordinate. So these are the what? So f of x1, let's say we have f of x1 here and f of x2 here. So this is f of x1. This point is f of x1. This point is f of f of x2. So the function point this is x2, f of x2, x1, f of x1. And let's say we have a graph like this. Okay? Is this a function, this graph? Yes, we can see vertical line test satisfies this, right? So this is every time you see a graph, curve, you can check on that in your mind. Is this a function or not? Okay? Just apply the vertical line test real fast, like mental math thing. Okay? Okay, so now, what this means, if this is the case, look at f of x1. Is f of x1 less than f of x2? According to this diagram, f of x1 value is this, f of x2 value is this, f of x1 value is less than f of x2 value. Right? It has to be all the x values in between these two. This should be the case. Then we say the function is increasing for this domain. From this domain, for this domain function is increasing. Are you following? For any 2x value in this domain, any 2x value, if this condition satisfies, okay, this is actually open. We don't have to pick that point. Okay, so any two x value in this open interval, if this condition satisfies, this is called what? From here to here, function is increasing. You can see it's always increasing. Y value is always going up, when the x value is going up. Right? It's like positive slope. Remember we talked about positive slope? It's a line going from left to right when x value, I talked about this, right? Positive slope. This is now, we can't say positive slope because this is curves. We are going to discuss like this now. Okay? So, So it says in the interval. Okay? So what is the interval here? The book has not given the interval. It says in the interval, but it's not very clear what the interval means. This interval, right? In this interval. For all values of x in this interval, where x1 and x2 satisfies. Okay? So you guys understood this. Anybody first question regarding this? Okay. So now we are going to go to the next part of this, which is part, I'll do some examples after this. This is part A. No, I'll go through as number 4, number 5. Number 5. Let me erase this guys, I'll go over here. So what else it can have, function can have? When it's increasing, yes, we can also have, a function can also be what? Decreasing. So we are going to have decreasing function. So the definition for this is also on the same page, page 203. Decreasing function, a function f is decreasing on an interval I'm going to say x1, x2, open interval. For any x1, x2 in the interval where x1 is greater than x2 implies what? F of x1 so do you guys understand this? Right? So whenever a function is decreasing, this is the diagram we have to come up. We know the situation. We have to pick up an interval first, right? Pick up an interval. We are going to say x1 here, x2, this is the interval. In this open interval, okay, it's x1, x2 open interval. Any type of x1, x2 inside the interval, okay. You know what guys, let me do this like this. I'm going to call this interval AB and x1, x2 inside the interval, okay? So I'll call this interval AB. So we have an interval AB, open interval AB. Let's call that way, that's easier, okay? Any open interval AB, I'm going to call this so. So any open interval AB and x1 and x2 inside that interval where x1 and x2 are increasing values, right? x1 is less than x2 in that open interval. So I have to pick what? x1 value here and x2 value here. Now we need to come up with what values? What values we need to come up with? Y value, right? So I'm going to come up with y value, f of x1 here, f of x1 here, and f of x2 here. So in this open interval, we have a function going inside the interval for all these x values. And if we consider, what do you consider here? The two y values for these particular x values. For all x1, x2s, any two x1, x2s, inside this interval, what can you say about the corresponding y values? Always f of x1 is greater than f of x2. If you pick a x1 here, x2 here, that's the same. Y value is, first y value is larger, the second y value is smaller than the first one. It should be true for all the x values inside this interval. Do you understand that? If it's not true for at least one pair of y values, which is not true, then this is not increasing within that interval. It has to be all x values inside that interval, all 2x values, any 2x values. It should satisfy this condition. Do you guys see the y value here? This is the first y value, this is the second y value. This y value is bigger than this one, greater. So, any question? Are you guys seeing this for the first time, hearing this for the first time? No, right? You have seen it before, right? You have talked about, but you are not very quite sure exactly what the definition says. So now this is the time for you to really understand, and this is not a big deal. You are not going to forget the increasing means. When the x value is increasing always, y values also have to be, corresponding y values have to be increasing. What is decreasing means? But you need to say when the x values are increasing. X value is always going left to right. This is like negative slope now, right? But X value is always increasing within that interval. But however, within that interval, Y value is decreasing. It's like negative slope here. Okay? Only thing is, graph is not a straight line. It's the same thing for negative slope. We did draw the diagram for that. Okay? So, okay, we are good with this. Okay, the last part we have to do is a function is constant. So, what do you think function is constant?
Straight line.
So, this is number 6. Constant function. What is constant function means? It's the same thing when the X values are increasing within open interval. When X values are increasing, what is the Y value supposed to be?
Constant.
Y values are the same. So this is a constant function. X value is increasing, Y values are, particular Y values are the same. So if you take, this is f of x1, this is f of x2, these two are the same. F of x1 is the same as f of x2. Okay? So this is, we know a straight line, horizontal line is a function. Right? Okay, so we discussed this. Okay, so let's talk about another page 205, average rate change of a function. I'm going to 7. I'll do examples after this, okay? After I go through all the properties. Average rate of a function. Now, average rate of a function is given by, I'm just going to, this is more like again the slope of a function. Average rate of a function rate of change, guys, sorry. Change of a function. Change of f is the function, from x1 to x2. So within two given x values, domain values, we can find the average rate by using this formula. What is this value called? This is y2, right? Remember the y value? y2 minus y1 over x2 minus x1. So what if it's a straight line, what are we talking about here? Slope. So this is again average rate of a function means, rate of change of a function means this is the function, means we are going to use this formula. This is like the slope of a function. Only thing is that we know this means y2 value. Okay. So let me do an example here. So this is what example. Find the f of x is equal to, I'm going to say, x to the 3 minus 3x. So let's do this example from x1 is equal to negative 3 to x2 is equal to negative positive 2. So we need to find the average rate of change. Rate of change. So this is also test question. I will ask you to find average rate of change given a function, given two x values, within these two x values, within these two domain values, what's the average rate of change? Okay, so what do you need to do first? Write the formula. Right? So what's the formula here? Average rate of change. I can write like this, average rate of change, right? Of f, this is function f, is equal to f of x2 minus over
x2 minus x1.
It's very easy, guys, right? See, all you have to do is remember this. Now what do you need to do? What is your x2? 2, right? So f of minus f of, are we good? Divide by 2 minus x2 is 2 minus negative 3. Very easy, very easy. This is like you're looking for slope. Now we know how to evaluate f of x2. We already know this. We have done how to evaluate given function. So what do you need to do? F of x is, we know the function, 2 to the power 3 minus 3 times 2. x3, I mean you can just write this, but I'm just doing the whole evaluation here. Subtract, I'm going to put brackets inside here because I need to subtract, right? F of x to the power 3, x means negative 3, correct? So negative 3 to the power 3 like this class minus 3 times negative 3 close bracket over 2 plus 3 is 5. So just simplify this. So I'm going to go here average rate of function is equal to, this is 8 minus 6, subtract inside the parentheses, negative 27, we know how to evaluate that, negative, negative, over 5. So do the math correctly here. 8 minus 6 minus inside the brackets.
8 minus 8.
Minus 18, minus times minus is now plus 18 over 5. What is this equal to?
4 or 5, so 4.
2, 20 over 5 equals 4. So that's the average rate of the function. Because the function is, we don't know whether the function is increasing, decreasing, but we know if you take the average rate where the function is moving, average rate is 4. Okay? Okay, so this is very easy. Right? Average rate of function. Just know how to use the formula. This is more like finding the slope of a function, right? Okay, finding the slope of a straight line. Okay, so the next thing we need to know is everybody okay so far?
Yeah.
Alright, good. Number 8. Number 8, we are going to discuss even function and odd function. Okay? So number 8. Even function. This is page 206. Even function. Now the definition says this. A function, this is the definition. A function y is equal to f of x. A function y is equal to f of x is even if each x in the domain of f, each x in the domain of f, then f of negative x is equal to f of x. If this condition satisfies, it's called an even function. Okay? So for an example, the functions are graphs, we know this, so functions can be given as graphs. So some graphs are, for example, this, it's like this. What is this graph that we discuss?
Parabola.
Yeah, we gave this was the basic one, we gave a name to this function. What's the name we gave for this function?
What?
Parabola.
What's the name we gave for this function? What's the basic function? X squared, very good. This is y is equal to x squared. Or we can say f of x is equal to x squared. This is the basic quadratic function, right? We know for this, pick any x, each x. For each x in the domain, in this domain, pick any number in the domain. Domain is, we know, all real numbers for this, right? So for any x, what is happening here? Let's take x equal to negative 2, okay? Or x equal to positive 2. So if x is equal to positive 2, now check here. Is f of 2 is the same as f of negative 2. This is, for each x we need to check whether this is the case. Every x in the domain. Are you guys following?
Yeah.
So what do we have here? What is f of 2 in this, if it's x squared, what is f of 2?
4.
F of 2 is 2 squared, right? For this function. For this function, we are discussing for this function, is equal to, what is this? Negative 2 whole thing squared, right? So isn't this the same? 4 is equal to 4?
Yes.
So if this condition satisfies, this is what called even function. For even function, for all x in the domain, all x, every single x, x of f of positive x need to be the same as f of negative x. So you guys understand the definition, right? Okay. So this is a good example for that. So that's the even function. And now we are going to discuss odd functions. There's a lot of properties, right? Okay, so the next definition is odd function. This is the next property. Next property of the function is an odd function. So we have a lot of things to check on a function now, not just domain range. Okay? So odd function. So what's the definition says? A function y is equal to f of x is function, or you can say function f of x is odd if for each x in the domain of f, the function y is equal to f of x is odd, is an odd function for each x in the domain of f of x. What condition we need to have here? F of negative x is equal to negative f of x. We need to satisfy this condition. If we can satisfy this condition, we are going to say it's a odd function. So we need to do we need to do some manipulation to discuss whether this is an even function or odd function. Okay? Even functions are easy to check, but odd function we need to do some manipulation work. So I'll do an example for this. Example. Let's take f of x is equal to x to the power 3. You guys familiar with this? What did we call this function? What is it called? Cubic function. You know exactly how to graph this. You know the domain, you know the range, you know the x-intercept. You know where to where function is increasing, where to where function is decreasing. You know the shape. You know it's not a straight line. You guys, I covered all, this is why I covered 2.3 at the beginning. 2.4 at the beginning. Do you guys see that? 2.4 I covered at the beginning. I have my reasons why I do that. The book is doing all this later on. Now I have done all that before. You guys have a very good knowledge of all the functions that we have graphed. I have given 7 different types of functions. So all those 7 different types of functions, you can ask these properties now. Is this function this? Is this function that? Is this function this? Is this function containing this property? Okay? So because that's why I did all those functions at the beginning. Because then we can refer to them. So you know this. And we know the graph of this, so I'm not going to discuss the graph of this, how we know it goes like this, right? So let's check on this now. Right now we are only checking whether it's even or odd, right? So what do you need to check? We need to check
X values.
if f of negative x is the same as negative f of x. We need to check this condition. We don't know yet. So pick any x. What x value you want to pick? Let's pick x equal to 2 or x equal to 3. Doesn't matter. Any x for every x in the domain. What's the domain for this function?
All real.
Negative infinity to positive infinity. For any x in the domain, it should satisfy. If one x in the domain doesn't satisfy this, then that's not an odd function within that interval. Or you can say within an interval, the function is odd if all x within that interval satisfy this condition. Do you guys understand the language? What I'm talking? Yes, thank you. Okay, so we picked what value? Check for any x. Let x be any number, let x be 3. Okay? Check. F of, what do you need to check for now? Negative 3. What is f of negative 3? Now you need to, because, okay, I'm just going to do f of negative. Let's pick f of negative 3. What do you get here? What do you get here? X to the power 3 here, right? So, negative 3 to the power 3, which is equal to negative 27. Now let's do f of, this is negative f of x, right? Now let's do f of just 3, negative outside, okay? So, negative outside, f of 3 is what? Just 3 to the power 3, correct? Which is equal to, this is 27. So do you guys see, if you take the numerical values, they are the same. Okay? Numerical values, they are the same. But to show this, we have to show it algebraically. If you show this, you are just showing it numerically for one x value. So this is what we are supposed to do to this. So we are going to say f of negative x. We are checking whether this is same as f of negative f of x. Okay? What is f of negative x?
27.
So this is how we are going to check for this, guys. So I'm going to do the checking algebraically. This is equal to, so what is f of negative x? X to the negative x to the power 3, like this. F of negative x, correct? So work with this now. Now I'm going to rewrite this as, we know this is negative x to the power 3, like this, right? Get rid of parentheses, that means this, right? Now I'm going to rewrite this, leave the negative sign out. What is this? F of x, right? Isn't this f of x? Because we said f of x is equal to f of x is equal to x to the power 3. Right? This is f of x, this means f of x. So we are working with f of negative x, we are working with f of negative x. So on this side, left hand side is f of negative x. And we are literally showing, we are actually showing that f of negative x is equal to negative f of x. Okay? You guys following this? So this is what you algebraically what you need to show. So this function is odd function. You do when you do more examples on this, you get familiar with this. Okay, right now if it's little abstract, it's okay. Okay, I'll do more examples on this. So I'm going to do more examples on this in a few minutes. Odd function, even function, we did this. Okay. So the book has this example, I can do this example also for So example, so this is like a test question, is f of x is equal to x to the power 3 minus 2x, I think. Is odd or even function. And you need to, so given a function, you need to describe why you are calling it odd, why you are calling it even. So first let's check for odd here. Okay. So we have to do it, we discuss it numerically, but now we have to show it algebraically. When you show it algebraically, that means we are discussing for all x values in that domain. If I showed you numerical examples, you can pick any and say, yes, this is true, but you can't pick all the numerical values within that interval, right? So we have to show it algebraically. So in other words, we have to show, what do we need? So we are going to check for odd, right? I'm only asking whether this is odd or even. Sometimes some functions are neither. I'm just asking odd or even. If it's odd, you say odd. If it's even, you say even. So what do you have to do here? Work with f of negative x. For odd functions, we have to work with f of negative x. So what is this going to be? Negative x, so instead of x, you put negative x. Minus, are we understanding this? Now what do you need to do? Now simplify this and work with this. Simplify this, what do you get? What do you get? Negative x to the power 3, positive x. So we work with this now. So this is still f of negative x is equal to negative x to the power 3 positive x. Now we want to get like this whole thing is equal to negative f of x, right? We want a negative sign outside. So therefore I need to pull a negative sign from this. So I'm kind of manipulating the work. You see, remember I said we had to do some kind of manipulation here to show this rule. So what do I have to do here? Pull a, because that's my objective, I have to come up with a negative sign outside. So I'm going to pull a negative sign out. If I pull a negative sign out, what should I write here now?
X cubed minus
X to the cube minus
X.
x. So this means the same thing, I just rewrote it differently because I want to show a negative sign outside. So now this is equal to negative sign I keep inside my brackets. What do I write here? Now look at all these together. What do we have here? If you look at all this together, what is that?
F of X.
Isn't this f of x?
Yes.
It's what f of x is given to you like that, right? That's f of x. So instead of all these, now I can write this is here, this is my f of x. So you have to do like a tiny manipulation, and once you do few examples, you get familiar with the type of manipulation you're supposed to do. Does that make sense? So what do you write here now? This whole thing means f of x. You have to like think, okay? So we just showed here, we just showed f of negative x for this function is the same as negative f of x. We just showed that. This is the work, so you have to show this work, guys. Little manipulation. You can't just show with the numericals only. You can check with certain numericals so far you understand it. If one numerical doesn't apply this rule, then it's not an odd function. So you know it. It's one count example doesn't apply the rule, you can eliminate saying that it's an odd function. So that's a good way to check with numericals, right? You only need one. Okay? But to show it algebraically it's an odd function, you need to do this kind of proof. This is more like a proof. Show that this is an odd function. Okay? Questions?
So would you have to do the checking with numerical or?
No, you don't have to do the checking. I just showed you the checking with numericals for you to understand what it means. Okay? So you don't show with the numerical checking, but you can do all anytime. But also it's important, if you want to verify that it's not an odd function, if one numerical value doesn't satisfy the condition, then it's out. Okay? It's like, it's always, mathematics is science, it's very precise. It's like saying like you have to have this condition, but if you have one, then you don't get into that family. It's like, in order to graduate, you need to have all this. If it's one class you are not having, right, you can't graduate. The same thing, right? I'm sure you guys had a question here?
Yeah, so I don't understand the whole idea, like the odd even function. So even like I'm trying to figure out like, so if f negative x equals f of x,
Okay. I do understand why you're thinking like that. Why it's not like you're not going to get this understanding as soon as you see it's getting a little abstract. Okay, you're not going to. It's like you're adding 25 and 77 is whatever. You understand exactly how to add because you have done the addition so many times. Or even multiplication, or even solving little equation. You have done it million times, right? So it's easy to understand. But now we discuss a brand new definition, okay? And I took a lot of time to explain why this definition means what, okay? And I gave you, and you have to understand the previous work also. What is a function? What are the other domain of a function? What are the other properties of function? All that you need to have understanding. Now with all the understanding, this is a new definition that we discussed today. So if you are not understanding, I'm sure most of you guys got the understanding, But if you're not understanding completely like the way you're supposed to understand, like you're doing a multiplication table, it's okay. If you're not understanding, don't worry about it. What you need to do is go home and read the definition again and again, take some time, read and see what it makes sense to you. Overall, you understood the property, what I talked about. But yes, if you come to my next class meeting and I'm talking about an odd function, and if you didn't read and understand exactly what it means to you and it didn't satisfy your thoughts, you're going to again be like not very clear of the next class meeting discussion. So yeah, you have to take time now because this is brand new definitions and it's not going to retain in your memory. You're going to forget, but you can your brain is set up to understand this now because you have done bigger stuff. That's why, for you to like, when you go to pre-calculus class, if you not have understand this stuff really well, you're going to have hard time understanding. Because you're going to say, oh, I don't get it. That's because you have not given a lot of thoughts to little definitions like this. So what you need to do, go home, read, understand, and tomorrow next class meeting, if you still have questions, you can talk to me.
I mean, yeah, I get it. It's just like, it is like vaguely simple.
Yeah, I think you understood. All what you have to do is, all what you need to do here, guys, read the definition, word to word. It's like you try to understand the meaning of a word, right? You go to the dictionary and read the definition, word to word, until you understand. Then you get an understanding about that word. This is the same thing. You need to read the definition. You need to take time and read the definition. Okay? So when you're reading definition, little thing like this, for each x in the domain, so you need to know the word domain means. If you don't know what is domain means, this definition means nothing. Are you following what I'm saying? So it's like when you're reading a definition of a word, if you don't know the other words, meaning of the other words in the definition which is describing that word, right? You will still not understand the meaning of that word. So this is why we have to understand the beginning stuff. Okay? So I'm sure you guys, every definition I wrote on the board, you are very capable of understanding. You have the brains to understand it. You have done this stuff, we have worked on it, and you are good with it. Trust me, you are good. Okay? You are really good at it. In case if you are not good, what do you need to do? Let's say you are reading a definition and you are not understanding one of the words that's in the definition describing that word. What do you need to do now? Look up that word. That's exactly what you do, right? You look up that word. What does that mean for me to understand this? So you do the same thing here. You're reading this definition and you don't understand what domain means, go back, read the domain means. It's the same thing. We were describing increasing functions, right? We were describing discretion functions. I gave the definition, word to word, and you understood the definition. But it takes time. I went through lots of definitions today, like 5-6 definitions. It takes time, everything together. It's kind of overwhelming now because I did all this together. But if you take your time, go back, read, understand, it's okay. You will get this. It's like anything, if you learn a dance step, at the beginning you're going to think, oh my gosh, I can't do this, I'm not getting it by looking at somebody else doing, right? You're going to be like, feel kind of dizzy or I don't know, you can't coordinate those steps. But if you practice, you're going to see it's not a big deal, you can do it. So it's the same thing, guys. So it's okay. In case if you're not understanding, don't get frustrated. You are good to understand it. I know that. Okay? But then in case you still have questions, you're going to ask me after class. Okay? So I'm giving time for you to read the definitions first. Okay? Okay, so let's do a couple of other examples here. So this is a test question, given like this, is this the case? The other one is, so I'll do another one here. Example number 2, is f of x is equal to x to the power 4 plus 2. So for this, if it's, I'm asking only odd or even, if it's odd, you don't even have to check for even, just say odd, right? So this is an odd function, right? Odd function, so the answer to this is an odd function. So for this one, odd or even. So I'm going to check for odd here. Check for odd, how will you check for odd? f of negative x is equal to negative, we are running out of time, so we are going to check for this, right? So check f of negative x to the power 4 plus 2 is equal to, this become positive x, correct? X to the power 4, positive x to plus 2. So is there any way I can pull out a negative sign and write this as a negative function? Can we? No, right? I can't do that for this one, right? So what can I write this here? This is what? I can't pull a negative sign. So this I know this is f of x, right? So I was just checking for f of negative x and I end up getting f of negative x is equal to f of x. So f of negative x is equal to f of x. Wow, when we see this, what are we knowing from this definition? This is the definition for even. For all x, for any x in the domain of the function, given domain, f of negative x supposed to be f of x, then in that case, that function is a even function. So here you are, so that's because we are familiar with the, we know whenever we see this is an even function. That's the definition we did. So the answer to this is, so this is how we show it algebraically. Remember I showed you guys f of x is equal to x squared numerically. I showed every x in this domain, you can check this is an even function. Now we can also show this algebraically, right? We can also show this algebraically. So now we are just going, the function is f of x is equal to x to the 4 plus 2 is what? Is even function. So let me go quickly. Example number 3, f of x is equal to x squared 1. What do you need to do here? Same thing, what do you need to do? You're showing it algebraically. F of, always check for f of negative x. Negative x squared, correct? F of, come up with f of negative x and see whether we can make this negative f of x or f of x, right? So what can we make this into? This overall become x squared, and we know there's no way we can rewrite this as negative f of x, right? So this is what? What is x squared means here? F of x. So f of negative x is equal to f of x here. We just proved that this is also what? Even function. So this is, and I numerically showed that for all x values. So now you cannot show numerically. I just showed you guys to understand the concept, okay? So you need to always check for f of negative x and see whether we'll do more examples of this next class meeting as well, okay? So this is what it is, guys. Okay? Are we good? All right, thank you. Good class.